Hello everyone, and welcome to Section 5 of the in-tier online Java training tutorials. In this section, we will go over arithmetic operators for addition, subtraction, multiplication, division, and modulo. After that, we will go into Lab 5.1, and then we will talk about increments and decrements, and then Lab 5.2, and then we will talk about relational and conditional operators, as well as precedence and parentheses, and then we will go into Lab 5.3, and lastly, we will talk about casting and conversion for data types. Now, let's get into it. As I've already mentioned, in this section we're going to go over operators. First, we're going to start out with arithmetic operators. These operators include addition, subtraction, multiplication, division, and modulo. The sign that represents addition is the plus sign. The sign that represents subtraction is the minus sign, or dash. The multiplication is represented by the star. Division is represented by a slash. And modulo is represented by percent sign. Now, I know you guys understand addition, subtraction, multiplication, and division, but most of you are probably unfamiliar with modulo. Modulo is like division. However, instead of returning how many times 10 would go into 14, it would return the remainder, which the remainder of 14 divided by 10 is 4. Another operator that the plus sign represents is concatenation. Concatenation is probably a new word for you guys. Concatenation means the combination of two strings. So for example here, we have hello as one string and world as another. And then we concatenate them using this plus sign, and then they are being held by the variable complete. And then we can print out complete, and it will print hello world as one string. Because part 1 and part 2 as two separate strings were concatenated together to make complete, which is one string of hello world. Up next is Lab 5.1, Math Magic. So what we're going to do in this lab, and I'm going to walk you through it here in a second, but I'd like you to try it first without me, is create a class called Math Magic. We're going to add a main method. And something I don't know if we've mentioned in past sections, it's very important to memorize the signature for the main method, which is public static void main, and then inside the parentheses string open bracket close bracket args close parenthesis open curly brace and then close curly brace, and your code goes inside those two curly braces. Anyway, back to the lab. Within the main method, we're going to declare an int called myNumber. An int variable should point that out, and set the value to any whole number of our choosing. So it could be anything. And then we're going to declare another variable. This time it's going to be a double, which I know you guys went over in the last section with Leslie, called magic, and set the value to myNumber, so the value we had to myNumber plus 2. But we're going to do that by calling on the variable myNumber. And then we're going to reassign magic to magic multiplied by 2. Then we're going to reassign magic to magic subtracted by 2. We're going to reassign magic to magic divided by 2. And then we're going to reassign magic again to magic subtracted by myNumber. And then we're going to reassign magic to magic modulo 1. And what it means by modulo 1 is it's going to be kind of like divided by 1. Print the value of magic once we've done all of this. And no matter what the value of my number was, the result of magic should always be 0. Now, what I'd like for you to do is I'd like you to try it by yourself. So I'm going to sit here for just a second. And then I'm going to go into it and I'm going to code this. And hopefully it'll answer any questions you may have if you have a hard time figuring it out, which is okay. It's only the 5th section. So first thing we are supposed to do is we are supposed to declare a class called Math Magic. I hope you guys are still using proper naming convention. And then we need to add the main method. And remember, the signature is public static void main open parenthesis string open bracket, open bracket, close bracket, args, open curly brace, close curly brace. Now, inside of the main method, we're going to declare a variable, an int variable. So we're going to declare int my number, which, as you remember, the proper naming convention is lowercase for the first word, capital letter for the rest of the words, the beginning of the rest of the words. So int my number equals, and I'm going to go with my lucky number 7. So now int my number equals 7. And next we're supposed to declare a double. So we're going to do double magic, lots of misclicks there, equals my number plus 2. Now, if you just said 7 plus 2, or whatever your number was for my number, that would also work. However, the issue with that is if you were ever to assign my number to a different value, you would then have to go into Magic and reassign it. This way, you only have to reassign the value one time by assigning it to my number automatically, and then calling on my number to add 2 to it. Now we want to do magic equals magic star, because that's multiplication, times 2, semicolon. And then we want to do magic equals magic subtracted by 2, semicolon. And then a magic equals magic divided by 2. And then we're going to do magic equals magic subtracted by my number. Oop, I forgot my number. And then, oh, and remember, Java doesn't care about white space. So we can do this on any of these, and it would still work exactly the same. And then lastly, we reassign magic, because equals is an assignment operator. So anytime you see a singular equals, that means assignment. So now we're going to do magic modulo by 1, which that means we're going to divide magic by the number 1, and it's going to either return, and it's going to return the remainder. And a good way, modulo is a very useful tool for determining if something is even or odd. Because if it's even, then it will come back as 0. There should be no remainder in the division if you divide it by 2. If it's an odd number, it will return a remainder of 1. And lastly, our task is to print out system.out.print line open parenthesis magic close parenthesis semicolon. Now we're going to save, and we're going to save it as math magic, because remember, you're supposed to name the class the same as your, or name the class file the same as the class declaration. And then you can go and save it. We're going to save it as a .java file. Then we're going to do save. Our next step is to compile our lab and make sure that there are no errors. So what we're going to do is we're going to open command prompt, which if you're on Windows is down in the bottom left corner. There's a small search bar. You can type in CMD and that will bring up the command prompt. Now, we're not in the proper directory. So a directory is where you save your file. So we need to go to CD desktop. That's where I need to go. This step will be different for you, but you need to know that the command CD stands for change directory, which then you need to learn the path of where your file is. As you can see, my path directory is C/users/al/desktop/section5. So that is what I'm going to type in. So I go to CD desktop, then CD section space 5 with a capital S. Now, remember our commands from our first lab is Java C, math, the name of our class, so MathMagic, .java. And if there are no errors, it will compile and show us that there are no errors. And it will simply print nothing. Then allow us to say, and if there are errors, we simply go back into our code and fix it and then attempt to recompile it. So then we will say Java, after we have compiled it, MathMagic. And we get 0.0. Now, let's test what happens if we change the value of my number. So last time, the value of my number was an odd number. What happens if we change it to an even number? So let's go with 8. And then we're going to resave. I click Control S. Up in the top left is the save button. And so now let's bring back up the command prompt and recompile this program. Now we're starting to run out of space on our command prompt. So another command I'm going to quickly teach you is very simple. It is CLS, which clears the command prompt of its history. Now it's clean and we can begin typing again without worrying about taking up too much space on the screen. We are still in the directory of desktop section 5, so simply all we have to do to recompile is the same command. Java C not hello world. MathMagic.java. Still have no errors, and now if we run it with Java MathMagic, we once again get 0.0. The next operators I'm going to show you are increments and decrements. And there are two types of increments as well as two types of decrements. There's the pre-increment and the post-increment, and then there is the post-decrement and the pre-decrement. Increments increase a selected number by 1, a positive 1, and decrements decrease the number by 1. Now there's pre-increment and there's post-increment. So the way that works is, see here in the system out.println. What will happen is as it's being compiled, it will see 11 minus number. At this point, number equals 0. And since it has a post-decrement, it will wait until it is done doing this operation, so 11 minus number, before it decrements the value that number holds, which is currently 0. So it will print 11. And then after that, number will equal -1. And if we were to print a number, it will print -1. Up next, we're going to do lab 5.2, incrementation. Just like with the last lab, I would like for you guys, after we go over what we're supposed to do in the lab, to try it yourself without my help. So just pause the video. And then after that, I'm going to walk through it, and hopefully that'll answer any questions that might come up while you're trying to do the lab. All right. So the first thing we're going to do is we're going to create a class called increments are weird. And they can be pretty weird. So yeah. We're going to add a main method. Like I said, try to memorize the main method signature. Public static void main, open parenthesis, capital S string, open bracket, close bracket, args, close parenthesis, open curly brace. Your code goes there, close curly brace. And so then now within the main method, declare an int called my number and set the value to 8. And so then what we're going to do is we're going to print the value of my number with a pre-increment, print the value of my number with a post-increment, print the value of my number with a pre-decrement, and print the value of my number with a post-decrement. It's pretty simple. And so if you feel like you get stuck, what I would encourage is going back, not forward, first to see if you can figure out what might be the error based on the knowledge you've previously gained, instead of looking forward for the answer to be given to you. All right? Good luck, and check back in here in a second. First things first, I'm not on the notepad. First things first is class increments are weird. That's with proper naming convention. Open curly brace, close curly brace. Tab, enter. You don't necessarily need to do the enter, but it is good to tab it in for every line of code that's subsequent into that block. That way it's easy to understand and read. So public static void main string args. All right. Now we're going to declare an int variable. So int my number equals 8 system.out.println and it is a pre-increment, so we're going to do plus my number. Now this should print 9, and then we're going to go system.out.println my number plus. And this is a post increment, which means it should print 9, and then the value of my number should turn into 10. So we'll make a little note of that. My number equals 10. System.out.println. Now we're going to do a pre-decrement, which means we're going to reduce the value of my number by 1. My number. And that's going to print out 9. System.out.println. And now we're going to do a post decrement, so my number minus. Nope, that's not the button I wanted to click. There we go. And now the value, it's going to print out, so it's going to print out 9, but the value of my number equals 8. So now we're going to save it, just like we did last time. save button up here, or Control S. And then we're going to set it as a .java. And we're going to call it increments are weird. Save. And once we save it, all these colors should light up nicely. And so then we're going to open our command prompt, same as last time, CMD in the search bar for Windows. And then full screen, let me blow this up so you guys can see it. CD desktop, CD section 5. And then we're going to do our compiling command, which is Java C, or as I like to think of it, Java compiler. And then increments are weird. .java. Remember, you need the .java when you're compiling. Oh, and we have an error. This is what's nice about that. So all we have to do is bring up and see, it tells us what line too. So with the command prompt, it says line Java 9, error, package system does not exist. So with that, we can fix this by saying system, and then we're going to re-save it. We're going to open command prompt once again. We're going to run our compiling command again. Now that we have no errors, I'm going to say CLS, and I'm going to say Java, and then increments are weird. 9999. Yep. But the value changes. So if we went back into our code really quick, goes from 8 to 9, stays at 9 to 10, goes down to 9, and then stays at 9, and then goes to 8. So if I were to print in between, so here, well, actually, we know it's 9 for sure here. But then if I were to print in between the post decrements, system.out.println, and we just did my number, and then we did it again on line 11, system.out.println my number. And if you are wondering how I know which line it is, these on the left, 1, 2, 3, 4, 5, 6, 7, 8, line 9, line 10, and line 11. All right, and then we can resave it, pull up our command prompt once again, CLS, just to keep it clean, Java compiler, Java C. Actually, I could just use my up arrow to bring it up again. Compiles, up arrow, down arrow, because you have to go back to where that command is. Java increments are weird. I would recommend that you guys type this just so that it helps it stick in your brain. We run it, 9910 998. And that is lab 5.2. The next operators we are going to go over are relational operators and conditional operators. Relational operators can be used on both booleans and numbers. You should be familiar with the word boolean, as in the last section with Leslie, you went over what a boolean is. It simply holds true or false. So, actually, only the last two relational operators can be used with booleans, whether to check if they are the same or if they are not the same. Relational operators include greater than or equal to, less than or equal to, or not equal to. So, for example, and they return true or false. So int age equals 18. So age equals 18 would return true. So Boolean adult would equal true. But if you were 19 with age equals 18, suddenly this statement would return as false, and then it would say Boolean adult equals false. But you're over the age of 18, which means you are in fact an adult. So the better way to check this would be greater than or and equal to 18. Because if we only did greater than, if we did 18, it would return as false. You wouldn't be considered an adult. But if you did equal to, this statement would return true. So adult would equal true. And in the next section, we're going to learn how to really use Booleans. Take good advantage of them. But for now, we'll just learn about the operators. So the next thing we're talking about is not equal to. So it does almost the same thing as equal to, except for it does the opposite. I like how I said that. Anyway, age is not equal to 18, which this statement would come back as false because age does equal 18. But if we change 18 to any other number, it would turn into true. The statement would return as true because 19 does not equal 18. But if we change it back to equal, it would go back to false. False. Age does not equal 18 because 19 does not equal 18. Now, on to conditional operators, which are only used on Booleans. So first we have and, which is represented by the and sign, and there's shortcut and there is not shortcut and. Then there's or, which is represented by pipe, and there's shortcut or, which is the double pipes, and then there is singular or, which makes sure it checks both sides. There's exclusive or, which is very interesting, and then there's exclamation point, which stands for not. So first we'll talk about and. So if we do and, ampersand, ampersand, there it is, false and false equals false. However, if it was false and true, then it would turn true, or false still, because it wants both sides to be true, because it is looking for true and true. Otherwise, it's false. They must both be the same on both sides, whereas they return true. So if we really wanted to, 18 equals 18, which is a Boolean statement. So that, or is a relational operator which returns a Boolean. So this would return as true, and true, which would return true. But if we said 18 equals 19, then this would come back as false, as only one side is true. So this would be false and true equals false. But instead, if we used or, which is only looking for one side to be true, false or true would return true. But if we do true or true, remains as true. Now, to talk about the shortcut, as I said, for shortcut and shortcut or, what happens is, and I'll show you with the or, since only one side needs to be true, so let's say I have on this side 18 equals 19. These are both Boolean statements. 18 equals 18 and 18 equals 19. However, one side is false, and Java reads left to right. So after it does its processing of does 18 equal 18, and it says true, seeing as there's an or sign, it's not going to do the right side's calculations because it already knows that it's true. So it'll return true and not calculate the right side after the or because it already has a true and it only needs one side to be true. If it's double pipes, it does the shortcut. If it's singular pipes, even if the first side is true, the second side will still be calculated and see that it will, and this statement here returns false. But it would say true or false, it has a true, meaning the statement returns true. And the same thing for single and or double and. Shortcut, not shortcut. Checks both sides. For singular and, if the first side comes back false and the second side comes back true, for double, for shortcut, then once it sees that this is false, it's going to automatically say, hey, both sides aren't true, and I'm an and, I need both sides to be true to return true. So that's false, and this is a shortcut, so it's just going to go ahead and move on and not calculate the right side. Now, we're going to talk about exclusive OR. Exclusive OR wants one side to be true and the other side to be false. So this statement right here would actually return true. Let's do this. / true, or actually false, sorry. False, tab, true. It's currently what we're seeing here, right? 18 equals 19 is false, and this side is true, which means this statement will return overall as true, because the exclusive OR, which is the little caret here, wants one side to be true and the other side to be false. So if I did 18 equals 18, 18 equals 18, these are both true statements, and so this would come back as a false statement, this overall statement with the OR. Now, if we add not, which actually isn't a middle operator, it is added here. So, or on in front of whichever Boolean statement we are trying to affect. And that just basically means not. So it's the opposite. So since both sides are true, but since this side is not true because of the exclamation point, it then becomes false. And this statement then becomes true again because of the caret wants one side to be true and the other side to be false. This 18 equals 18. So the best way for me to show this is to put it inside of parentheses, actually. So 18 equals 18 comes back as true. But then the not, the exclamation point, makes it not true, which is false. But if it was false, so let's say 18 equals 19, which is not true. So this statement would come back as false, but then it's not false, which equals true, which then with the caret would equal false for the whole statement. But if I was looking for or, if I had or, then this statement would return true instead of false, which both sides right now are true because this statement is false, but then the not makes it not false. So if we did and, it would be true. But if we got rid of the not, this side would become false because 18 equals 19 is false. And since we no longer have a not, it is just false and true, which makes this whole statement overall equal false. Now, parentheses aren't required for any of this. These symbols, operators, all have a precedence, which means they go in a certain order, just like with multiplication, division, addition, and subtraction. Multiplication goes first, division second, addition, and then subtraction. Okay, so really quickly, I'm going to run through the precedence of operators. This is a complete list. It's found on the web page for section 5. So, because I know you guys aren't going to get this first try, I certainly didn't. So just come back and review it as time goes on, and it'll start to stick. So first is parentheses, array, subscript, so that's the brackets, and member selection. So, for example, system.out.println goes first because of the dot. And that is read left to right, parentheses, brackets, and periods. Very important, they go first. Now, post increments and decrements go before pre-increments and pre-decrements, as well as plus, minus, logical, negation, aka not, and then bitwise, completion, and typecast. So we'll get into casting right after lab 5.3, which is next. But casting is done with parentheses, and then we name our data type inside of those. But we'll go into that here in a second, even more. But just remember that it is right after post and increments and post decrements. And on the same level as pre-increments and pre-decrements. And then after that is multiplication, division, and modulo. Then after that is addition and subtraction, same as with the precedents of math from when you were in high school. Bitwise shift operators, we'll get into those more later, but remember how bytes are 18 bits, shorts are 16 bits, ints are 32 bits, and floats and doubles are 64 bits. So if we do a bit shift, it just moves the the ones and the zeros over in that direction. So now rational operators, so that's the greater than, less than, greater than or equal to, less than or equal to, or instance of, which we haven't gotten into yet, but we will eventually. And after that is equals to, or not equals, and then there's the singular and check, so the non-shortcut and. There's the exclusive or, and then there's regular or. And then after that is shortcut and, shortcut or. And then on top of that are the conditional statements of with question mark and colon. And then last is assignment operators. So that's why when earlier you were seeing age boolean, or boolean age equals, that equal sign goes last. And then here in a second, we're going to get into plus equals, minus equals, multiplication equals, division equals, modulo equals, or equals, exclusive or equals, regular or equals, bitwise equals. So we're not going to really get into the bitwise equals, but we will talk about plus equals, minus equals, multiplication equals, division equals, and modulo equals. This is assignments revisited, okay? So up until this point, the only assignment operator has been equals. There are more assignment operators. There is plus equals, minus equals, star equals, which is multiplication equals, division equals, and modulo equals. And here's how it works. So if we declare a variable, int magic equals 17, and then we do 17, or magic equals magic plus 2, which really says magic equals 17 plus 2, magic equals 19. Now if we reassign magic 17, and then we do magic plus equals 2, is magic again equals 19. That is because plus equals is the same as magic plus 2, or magic equals magic plus whatever number. So plus equals is magic plus, or equals magic plus whatever number is being added here. Now this works, again, this works with subtraction, multiplication, division, and modulo. So if we were to place magic equals magic minus 2, which would then equal 15, the same thing would happen here if we did minus equal And this would then again equal 15. Now, a good way to remember this is op equals. So operator equals, and this can be done with any non-Boolean operator. So remember, conditional statement or conditional operators are Boolean operators. They work with Booleans. But and then there were relational operators and assignment operators and arithmetic operators. This works with arithmetic operators. It kind of combines assignment operators and arithmetic operators together. Now we are going to do lab 5.3, precedence. Just like for the last two, after we discuss what we want to do in this lab, I want you guys to try to do it on your own and go back if needed and rewatch some parts to find the answer before you watch me go through it. And then I'm going to go over it, and hopefully that'll answer any remaining questions after you have done those steps. All right. So first thing we're going to do is we're going to create a class called precedence. We're going to add a main method, which, remember, the signature is public static void main, open parenthesis, capital S string, open bracket, close bracket, args, closing parenthesis, open curly brace, and then our code goes there, close curly brace. So to demonstrate our understanding of precedence, we're going to rewrite the operations from the MathMagick class, but complete the declaration, assignment, and operations regarding the magic int on a single line. We're limited to only using 2 sets of parentheses to override precedence. On the second line, print the value of magic and make sure that it still equals 0. Your main method should only have 2 lines of code. The first one is the assignment, or the declaration, the assignment, and the operations. And then on top of that, and then the second line should be system.out.println magic. All right, good luck. Okay, so the first thing we're going to do, just like with every other lab, is we're going to declare the class precedence, and then open curly brace, close curly brace, main method. Nope, not it. Oh yeah, okay, we're good. Nope, I accidentally clicked cap box. Public static void main string args, open brace, close curly brace. Now we get only 2 lines and 2 sets of parentheses. So magic equals whatever number we so choose. I'm going to go again with my lucky number 7. And then remember, the first step is to add 2. Then we want to subtract 2. Or actually, sorry, multiply 2. Then subtract 2. Then divide by 2. And then modulo by 2. And with that, now let's change the precedence. Because remember, multiplication goes before division and modulo, which we want those to happen last. Division goes before modulo, addition goes after multiplication, and subtraction after addition. So first, let's add a parenthesis here to make sure that addition goes first. And then on top of that, we want multiplication to go before subtraction, and we want subtraction to go before division and modulo. So if we put in parentheses surrounding 7 plus 2 multiplied by 2 subtracted by 2, with that, this precedence. So here's how it works. So first, inside, Java will look at these parentheses and say, okay, what has the first operation in here? Well, since there are more parentheses, 7 plus 2 goes first. So now we have 9, and then multiplication goes before subtraction, so then it's multiplied by 2, and then all that's left within these parentheses is subtraction by 2, and then division goes before modulo, so then it goes divided by 2, and then modulo 2, and then remember, assignment goes last. So then magic is assigned 0. And then simply system.out.println magic semicolon. Now we're going to save it as a .java file. Precedence and then save. We get our fancy different colored text. Next we pull up our command prompt, CMD in the bottom left search bar for Windows 10. Let me blow this up again. And now we're going to go, just like last time, go into our directory, change directory to desktop. And inside of desktop, we're going to change our directory to section 5. And then we want to Java C or Java compile our precedence.java file up, and if we have an error, it tells us what our error is. We have 2 errors. 1, cannot find symbol magic, and I already know what my issue is. And then cannot find simple magic because variable magic has an error. So the way to fix that, very simple. I forgot to declare that magic is going to hold an int. Now if I save it and I bring back up my command prompt and I CLS just to clear it off, and now it compiles properly, and then I can say Java precedence, and now it runs returning 0. Now we can change the number inside of precedence.java to any number we want, which could be, let's do a really high one, 185 or 1085. So now, if we bring back up our code and we recompile precedence, and we CLS really quick, and we Java precedence, we once again get 0, which means we've successfully completed lab point 3. Now we are going to talk about data type casting. So there's upcasts and there are downcasts. Upcasts are implicit, which means that the compiler does them for you. Now, downcasts are explicit, which means you have to tell the compiler that you want to downcast. So, the first thing to go over is bytes. So if you remember your data types, there's bytes, shorts, integers, floats, and doubles. So if you are doing arithmetic using your arithmetic operators, plus, minus, multiplication, and division, and modulo, bytes and shorts automatically, implicitly, get upcast to an int. So there's going to be an error here because I'm trying to put it back into a byte. So I'm taking these bytes, and because of the arithmetic operator, they're turning into ints, and then I'm trying to shove it back into a byte without explicitly telling the compiler. So if I pull up my command prompt with CMD, oh, that's full screened on the wrong screen, and I full screen it, and I zoom in, and I'm going to show you guys a little trick here with the command prompt. So instead of saying CD desktop and then clicking enter and then doing CD section 5, we can just put a slash and do section 5. And so then, after doing that, we're going to say Java C example.java. Now we're going to get an error because byte answer is a possible lossy conversion from int to byte. So when we do byte plus byte, it turns into an int and then cannot be implicitly. So the compiler says, no, you have to tell me if you want to downcast, because there's possible lossy conversion. When there's possible loss of the data being whole, it can be lost in the transfer from an int to a byte, because an int can hold much more, a much larger number than a byte can. A byte can only hold from negative 256 to positive 255, I think. It might be slightly off on that, but it's around that area. And an int can go into the millions. So, with that, we're going to go back into an example, and we're going to add an implicit downcast. So we're going to say byte, and we're going to put the byte 1 plus byte 1 in parentheses as well. That way it knows to do this and then the conversion, because technically the conversion is its own operator. So we'll take this integer number that has been implicitly upcast and then explicitly downcast it back into a byte so that it fits into answer. So we're going to save, pull up our command prompt, and we're going to do CLS just to make it clean. And we're going to do Java C example.java, and there should be no errors. As you can see, we just did a successful downcast. Now, when we are downcasting from doubles and floats down to an int, there is a loss of precision. Remember, floats and doubles are the only data types that can hold decimal point values. Int cannot hold decimal point values. So, if we downcast a double into an int, there's a loss of precision, and the decimal point gets removed. So now answer equals 1. Because another thing to remember is when downcasting, it always rounds down. So it could be 1.9, or it could be 1.3, 1.2, 1.4. It will guaranteed always round down. And that concludes section 5. I hope to see you continue this course. Thank you very much. Bye-bye.